Hey, hi, hello, and welcome to the highly anticipated season of Binomial Theorem, the return. I know it's everyone's favorite thing from quarter one, so I just can't wait to get started. Okay? Binomial theorem, like the question says here, it says use the binomial theorem to expand the expression 2x plus 1 to the power of 4. Reminder that binomial theorem is essentially a shortcut to our box method. What this really represents is 2x plus 1 times another 2x plus 1 times another 2x plus 1 times a fourth 2x plus 1. We could either spend our time box methoding out every single one of those, or we can use our binomial theorem. Now first, there are a couple things that we want to know or remember about binomial theorem that's going to make this a little bit easier. First thing we want to know is the number of terms in our final expression, or our final answer, and I can't fit the word expression there, but pretend like that says expression. The number of terms will be 5 because it is one more than the exponent given. So our exponent given here is 4. The number of terms will be one more than the exponent given. Okay, the exponents must add up to 4. So in each part of the expression, the exponents must add up to 4 because that is the exponent on the outside of the parentheses. And then there are two places that our coefficients come from. The first one is Pascal's triangle. Okay, remember this bad boy, Pascal's triangle. I'm not going to ask you to generate your own. You all have copies, but that is where coefficients come from. And it comes from the coefficient of the variable in the original expression. So original expression coefficients. Okay. So now that we know all that, we can go ahead and get started in actually doing our binomial expansion. So first thing, I know the number of terms. So the first thing that I always do is write the number, or write blanks for the number of spaces. So here, if I know I have 5 terms, I'm going to do 1, 2, 3, 4, 5. Each of these should be separated by an addition sign. Okay, so first thing I do is I literally just write the blanks because it makes it a little bit easier, I think, to solve. Okay. The next thing that I do is I go through and I write the coefficients from Pascal's triangle. So the second thing I do is I do the coefficients from Pascal's triangle. Okay, again, the exponent tells us which row of Pascal's triangle to be on. If my exponent is 4, that means I'm going to be in row 4 of Pascal's triangle. Reminder that this first number at the top doesn't count. Notice that row 4 has 1, 2, 3, 4, 5 terms, just like we said before. So first thing, we just copy these over into our expression here. So I've got 1, 4, 6, 4, 1. Notice that that matches exactly to row 4 of Pascal's triangle. Right here, 1, 4, 6, 4, 1. Okay, so after I've written in my coefficients from Pascal's triangle, the next thing I'm going to do is look at my first term in the expression. Here, that is 2x. So I'm going to take my first term, and I'm going to start with an exponent of 4. And decrease by 1. Decrease by 1. Okay, so I've got 2x, that is my first term. So I'm going to do 2 to the 4th, x to the 4th. Then my exponent is going to decrease by 1, so this will become 2 to the 3rd, x to the 3rd. Then 2 squared, x squared. 2 to the 1st, x to the 1st. And then finally, 2 to the 0, x to the 0. Okay, so it decreased. I went 4, 3, 2, 1 with my exponents. 4, 3, 2, 1, 0. Okay, now I'm going to do something very similar with my second term. My second term here is the 1. I then am going to take my second term, but this time I'm going to start with an exponent of 0 and increase by 1 each time. Okay? So I would start with 1 to the power of 0. Now notice here that color-coded, my exponents add up to 4. 4 plus 0 gives me 4. Okay? So I started at 0, I'm going to increase by 1. Then I would do 1 to the power of 1. Again, color-coded, 3 plus 1 gives me 4. So that's how I can double check that I've done it correctly so far. Then I've gone 0, 1. This should be 1 squared, 1 to the third, and 1 to the fourth. Okay? Now the final thing left here to do is just to simplify. So the final step is to simplify. How I do that, I redraw my blanks. And the first thing that I bring down is the variable because I'm not going to multiply those. So the first thing that I bring down is the x value. So this would be x to the fourth, this would be x to the third, then bring down the x squared, x to the first, and x to the 0. So I bring down the variables first, and then whatever's left over, I multiply together. Whatever's left over, I multiply together. So here I've got 1 times 2 to the fourth times 1 to the 0. I'm just going to plug that directly into my calculator. 1 times 2 to the power of 4 times 1 to the power of 0. And that gives me 16 for this one here. I'm going to just repeat the process, making sure I've already brought down my variable. Here I'm going to multiply together 4 times 2 to the power of 3 times 1 to the power of 1. And that gives me 32 as my coefficient here. Next one I'm going to do is this one here. I've already brought down my x squared, so what's left to multiply is 6 times 2 to the power of 2 times 1 to the power of 2. That gives me 24. Last two, I think you can still see my calculator. Last two, this one is 4 times 2 to the power of 1 times 1 to the power of 3. Oops, typed that in my calculator wrong. Times 1 to the power of 3. That gives me 8. And on this very last one, I have 1 times 2 to the 0 times 1 to the fourth. So 1 times 2 to the 0 times 1 to the fourth should give me 1. Okay, and that is my final answer. I could clean this up a little bit. This doesn't need an exponent of 1 because x to the power of 1 is just x. This x to the power of 0, anything to the power of 0 is 1, so I can eliminate that as well. Okay, but it is equally as correct if you leave this as x to the power of 1. So that is our binomial theorem. I know it is tedious, but I think it is slightly better than box method, so worth knowing. At this point, you are going to pause and practice those last two practice problems below, and then you are done with your day 2 review packet. Woo, go you, you are awesome.